Hey all, today we are going to learn about polynomial functions and models. So the first thing we're going to talk about is the degree of a polynomial, and what that just means is for your x value, what is the highest exponent in your function. So if we look at example A, we see 2 minus 3x to the fourth. The only x value we have is 3x to the fourth, and it has a degree or exponent of 4. So our degree equals 4. The next one is g of x equals the square root of x. We can rewrite the square root of x to have the exponent of 1/2. The degree of a polynomial function needs to be an integer or a whole number. 1/2 is not, so this is not a polynomial function. C, we are looking at x squared minus 2 divided by x cubed minus 1. This is a rational function where the highest degree is in the denominator. So, and in rational functions, it's not a polynomial, so rational. F of x equals 0 is a constant function, and even though it doesn't have an x value in it, it just has a degree of 0, but it is still a polynomial. So, no degree, yes. Same with g of x equals 8. It's a constant function, no degree or a degree of 0. So, yes. Lastly, we have this negative 2x cubed times x minus 1 squared. To determine your degree, you need to have a single polynomial instead of things being multiplied to each other. So let's start expanding this. I'm going to start with rewriting it as negative 2x cubed times x minus 1 times x minus 1. You rewrite x minus 1 squared by multiplying it by itself twice. So let's start expanding this and foiling. Negative 2x cubed times x is negative 2x to the fourth. If we remember, when you multiply exponents, you add them. So this is x cubed times x1, so 3 plus 1 is 4. Then negative 2x cubed times negative 1 is positive 2x cubed. And then we're going to multiply this by x minus 1. Again, let's FOIL. And we get negative 2x to the fifth plus 2x to the fourth plus 2x to the fourth, and then minus 2x cubed. This simplifies to negative 2x to the fifth plus 4x to the fourth minus 2x cubed. We have multiple x values, but our highest exponent is 5, so our degree equals 5. All right. The next part, we're looking at the zeros of the function. And when you have x minus r equals 0, then you would have x equals r. So that's like when we're trying to find the x-intercepts of a quadratic, we end up having something like x plus 2 times x minus 3 equals 0. And we end up with x equals negative 2 and x equals 3 by setting both equal to 0. Because we would do x plus 2 equals 0, minus 2 minus 2, x equals negative 2. And as you notice, it's the opposite. So in our parentheses, we had an x plus 2, but our 0 is really negative 2. So let's look at these zeros and apply that same rule. So if we have a negative 3, in our parentheses, we're going to have an x plus 3. And then we have a positive 2 as our 0, so we're going to have x minus 2. And then for the 5, an x minus 5. And now we want to find the polynomial. So we're going to go ahead and FOIL these out. So I'm going to start with x times x is x squared. X times negative 2 is negative 2x. 3 times x is 3x. 3 times negative 2 is negative 6. Simplify this to x squared plus x minus 6. And we still have to multiply this to x minus 5. We get x squared times x is x cubed. We get negative 5x squared plus x squared minus 5x. Don't forget the negative 6 to both as well. So negative 6x and then plus 30. Now I'm going to combine my like terms, the x squareds and the x's. So this simplifies to x cubed minus 4x squared minus 11x plus 30. Next, we're going to be looking at the multiplicity. So the multiplicity is just by those exponents. So like if we go back to the last example, x plus 3. If we look at this, it has an exponent of 1 with it. And this would mean the multiplicity is 1. The multiplicity is that exponent. So our exponent was 1, so our multiplicity is 1, which means it's odd, which means it would cross through the graph. And what it means by it crosses through that graph, so our 0 here is negative 3. So if we look at our graph of negative 3, it would go through the graph. It would cross through it. But if it was even, say if it was x plus 3 squared, we'd have a multiplicity of 2, and this would be even. So it would just touch the graph at negative 3. It wouldn't actually go through. So let's go ahead and do these examples. First, you want to find those x and y intercepts. So let's find the x first by setting each parenthesis equal to 0. So we have x plus 1 squared equals 0, and x minus 2 equals 0. Add 2 to both sides, x equals 2. And then for this one, we're going to start by square rooting both sides to get rid of that squared and have x plus 1 equals 0. Subtract the 1, x equals negative 1. The y-intercept, we plug in 0 for x and find y. So we would have 0 plus 1 squared times 0 minus 2. Or, times 0 minus 2. So this is 1 squared times negative 2, which is just 1 times negative 2, which equals negative 2. That is our y-intercept. Next, we are looking at each of those x-intercepts and determining if the graph would just touch or would go through. So looking at that multiplicity. So let's look at the x equals negative 1. What's going to happen there? So it came from this piece of the equation, and it had a multiplicity, so its exponent equals 2. That means we have an even multiplicity, which means it will just touch. The graph will just touch at x equals negative 1. Now let's look at x equals 2, and this came from x minus 2. It really has an exponent of 1 right there, so m equals 1, which is odd, which means we are going to cross through the graph at the x-intercept of 2. The last thing we are going to look at is the end behavior of the graph. So determining if our graph has both ups, if it has a down and an up, if it has 2 downs. We're going to determine what that looks like looking at the equation. So to determine that, you need to know your a value, which is the very first coefficient of your polynomial of the highest degree. So we are going to expand this function first to get that single polynomial. So 2x plus 1 times x minus 3 times x minus 3. I'm going to start by multiplying x minus 3 times x minus 3. I know this is x squared, and then that is minus 6x plus 9. This is called a perfect square. Next, I'm going to distribute that 2x plus 1. So that is 2x cubed minus 12x squared plus 18x plus x squared minus 6x plus 9. Now combine your like terms. So 2x cubed minus 11x squared plus 12x plus 9. Alright, next we are going to determine the a value. So the a value is from that highest degree, so 2. So a equals 2. And we can see that that is bigger than 0. So we have an odd end behavior, which means it's going to look like the cubic function of 1 being down and 1 being up. Next, we are looking to find the x and y intercepts. So we'll do again, let's solve for the x. So 2x plus 1 equals 0. X minus 3 squared equals 0. That is 2x equals negative 1. X equals negative 1 half. Here we get x minus 3 equals 0 by square rooting. X equals 3. Lastly, the y-intercept, plug in 0 for x. 2 times 0 plus 1. 0 minus 3 squared. So that is 1. That's negative 3 squared, which equals 9. Which equals 9 times 1 is 9. So that's the y-intercept. Lastly, we're determining the multiplicity. So at those x-intercepts, are we going to cross or are we going to touch at that x-axis? So let's look at x equals negative 1 half. That came from 2x plus 1. So its exponent of this parentheses was 1, which is odd. So it's going to cross. Then we have x equals 3, which came from x minus 3 squared. It has a exponent of 2, so multiplicity of 2, which is even, and it will just touch at this point. And that is all. So please ask me if you have any questions.